This video provides a quick overview of how to weld Raex steels. This is Gustav. He is very particular about his appearance and his work, which is making high-value steel parts. Today, Gustav needs to weld a Raex plate to build an upgraded wear part for his mining customer. Raex is ultra-high-strength steel, so Gustav knows that he must use a low-hydrogen filler metal and the right cooling time for reaching optimal properties for the welded joints. To also reduce hydrogen at the weld spot, Gustav starts by making sure the surfaces are free of grease, scale, oil, dirt, moisture, and paint or primer. To find the recommended working temperature, the amount the plate needs to be preheated prior to welding, Gustav uses the Raex Smart tool at raexsteel.com. On Raex Smart, he enters the product type, its grade, thickness, width, and length. Raex Smart immediately informs Gustav of his preheating temperature in centigrade. In all cases, the steel must be at least 20 degrees centigrade. If the steel isn't 20 degrees centigrade, or Raex Smart recommends a higher temperature, Gustav uses torches or ceramic heating pads to achieve the necessary temperature. Welding consumables for mild steels can be used for Raex steel. It is recommended to use ferritic welding consumables with a low hydrogen content, less than or equal to 5 milliliters per 100 grams. That is, a hydrogen content class H5. Undermatching austenitic consumables are a safe choice, especially for repair welding. He then goes to the Raex Smart tool and selects his welding method, joint type, voltage, current, and the welding speed. This way, he can find the recommended minimum preheating temperature and heat input to reach the optimal properties for the welded joint. Guidelines for heat input with different joint temperatures can also be found on Raex Smart. If doing multiple interpasses, Gustav would then measure the temperature of the welded joint and then use Raex Smart to determine the heat input based on the temperature. For the third interpass, Gustav would again measure the temperature of the welded joint and use Raex Smart to determine the critical working temperature based on the Smart chart. Interpass temperatures cannot be higher than 220 degrees centigrade, so before starting the next interpass, the temperature must be below 220 degrees centigrade. If heat input is too low, joints cool down too quickly, which increases the stress level and hardness of the heat-affected zone. If heat input is too high, joints cool down too slowly, which decreases the hardness, strength, and impact toughness of the welded joint. During all stages of welding, the temperature must be kept uniform across the entire part. With optimal heat input, Gustav can obtain the best properties for the welded joint, and he can be sure that the weld will not fail during the service life of the part. Raex steels are compatible with virtually all welding processes, and welding is straightforward when following the Raex recommendations. If Gustav has a particularly demanding or unusual weld, he contacts his material supplier. But most of the time, he just needs to use Raex Smart, with its interactive guidelines for both welding and bending. By using the recommended welding consumables, even the most demanding structures can be fabricated using Raex steels. Go to raexsteel.com to find Raex Smart. Soon, you'll be welding our hard, strong, tough steel with complete confidence.